in more of a human-centered AI, not just abstract theory, but how can we apply this thing? And that drew me towards embodied AI and robotics. So this is my story of like trying to know as much as possible within the field of computer science itself. And a master stroke is something which I call having an outstanding skill or trying to make a very clever move. And some of the ways that we can know is also knowing ourselves in this journey, that we want to know what makes us sad, happy, or motivated. So what I want to emphasize here is when you're trying to know yourself, try to do a SWOT analysis, which is strength, understand your strengths, weaknesses, what are your opportunities and what are your threats. And that's just unique for everyone. And more you gain experience, more you explore things, you try to get a better understanding of having your own SWOT analysis. So, so the next brush, I would call it to apply. And vaguely, you can think of applying knowledge to real world problems. To better understand what these problems are, you need to work with more experienced people. And that's where you need to apply for internships, job opportunities, research programs, even higher education schools. So that is something that I want to emphasize. Is you need to apply your skill. And if you get none of these opportunities because a lot of rejection is on the way, you can still polish your skills by applying them to a self-driven project. And just like the last one, master stroke is to just apply as you learn. And applying is something what polishes your knowledge. And without applying, you practically have no evidence that you'll know it. And if you won't apply, you're likely to forget it, and so will others. So all the things that I discussed in the knowledge brush was because I had applied for internships and applied for research positions for these roles. So it was me applying for the university lab at the start of my second year. And then it was surely a very steep learning curve, just right from freshman year. But the seniors there encouraged me to apply for internships at the end of my second year, which I was not at all confident in. But the key idea here was to have a practice mindset, that is just apply to prepare for internships that you might have to apply in your third year, in your pre-final year. And you can imagine at the end of your second year, you are gonna get a lot of rejects. But I was fortunate to get one of the opportunity to become a research intern at FZI Research Center in Germany, and instead of going for PS1. So I think that first opportunity, that early start, really inspired me for like looking for more research opportunities, and that made me confident to apply for, say, these scholarships such as MyTax and DAD that you have in your pre-final year. I was very hopeful about that, but I did not get selected, so that was a rejection. But I did get selected for MyTax Global Link Fellowship. And that gave me opportunity to explore some amount of machine learning. And then from there on, I got more confident. I knew what I wanted to go forward with. And that was when I applied for Mila for my thesis opportunity. I got some other good opportunities as well. And I kind of applied for jobs at that time and research program at Microsoft Research. So one thing to remember again is, even if you get more confident in your skills and abilities, it's still a very random process. So if something was unsure of, which I was uncertain about, I would have a backup plan. So in this case, there were jobs. You have typically placement sessions in your, yeah, as you enter your fourth year in your undergrad. That was a backup for me, like just to have a job. Um, and then the idea, you might be imagining that I've applied to so many different places. But the idea was that if something was new and it complemented what I had done in past, and I could bring something new, transferable skill to the table, I would take that opportunity. And I felt that such opportunities gave me a possibility to explore more in the start of my career. And you can imagine that as you progress further in your career, especially in professional fields, you get more specialized and there are lesser opportunities to explore. So this is where knowing your own self and some amount of self-reflection help, because we have to decide at one point what I want to specialize in. Um, so yeah, similar story continued when I applied for masters. There was with a practice mindset that even if I get rejected, it's okay. And when I applied for PhD, that was the reason. I applied to schools, I applied for jobs, I applied for AI residencies. Somehow it worked out that the research focus at the AI residency at Facebook matched with what my prospective advisor had in mind. And that's how I landed in the current opportunity that I am. Uh, I think if we can make this more interactive, it'd be less boring. So if you guys have any questions at this point, feel free to ask.
If anyone has any questions, I think you could just unmute yourself and
Oh, okay.
ask them.
Okay then. Yeah, so next, the final brush was, and the one that I was most afraid of was to network. And all these experiences for internships and starting from the technical community, ACM chapter, right till grad school, they gave me an opportunity to network, connect with peers, senior faculty, and juniors from different fields and specializations. And it was so one interesting incident that happened yesterday was my manager had a meeting to introduce me to other collaborators, and out of the four of them, I knew two of them. So one person was, I had attended her talk in Mila, and another person, we were discussing some user study experiments in which she was an engineer of. So it's interesting, like this is a small world, and if you try to find meaningful connections, it really like somehow it can lead to future collaborations, or just it can bring you opportunities in the ways that you have never imagined at times. So yeah, just to emphasize that you need to network proactively. You'll find so many seniors, juniors, batchmates, scholars, mentors, professors who have gotten some exciting job offers, higher education offers, and then there's so many interesting stories to learn from them. So you should definitely reach out to them. This current session is an excellent example of doing that. Um, and also look forward to go to conferences, career fairs, startup fairs, tech meetups. Even if you are not currently interested in joining those opportunities, it just gives you a good chance to communicate, to talk about your work, to learn about what others are doing, and eventually build a stronger network. One thing I want to emphasize here when I say network proactively, don't think of networking as straight up going and asking for a job or an internship or something. So even at career fairs or startups, like you would want to understand the other person, understand what they're working in, what they're excited about, um, and then figure out what exactly are they doing that links to you. Um, And that is helpful to have some meaningful relationship which lasts over years. Also, you kind of need to time your entry. So early on in any event or in school, when school starts, it's always easier to get into a conversation and build rapport with people. But you will soon realize as the groups get formed, one needs to be very careful in entering those groups so that they don't appear like they're pushing out of the way and making a bad impression. So yeah, networking is a very important skill. Um, I would suggest like you can ask questions in a discussion, genuinely meaningful questions to get a part in the ongoing discussion and connect with people. So yeah, these were these three brushes, and some tips about these brushes were like you can customize them. We all are trying to paint a unique picture with them. And for me, I was a curious kid. I've wandered into knowing, like, learning about genetics and astronomy and quantum physics, and so on. So, one thing in research is that you need to go into a depth of something. So, you eventually need to channelize your efforts and start focusing and developing your own ways of gaining and retaining knowledge. um, and that's about how I, instead of exploring the breadth, which was my natural tendency, I tried to focus on the depth of a topic more, um, more so now. And for applying, I would say I developed a practice mindset for myself that it's okay to fail, but it's not okay to not try at all. And this just thought just makes handling the rejections easier, that you are going to try for the same opportunity again, maybe prepared in a better way. And then finally, for networking, I mentioned that I find it particularly difficult. It used to get awkward in career events and conferences, but I've gained confidence and sheer experience over time. Um, One way of fostering in friendships during internships and masters was through discussing the recent projects or recent paper that has come out, or just bonding informally over board games or virtual game nights. So I would encourage you guys to develop your own ways of gaining knowledge, applying, and networking. So with that said, but remember to maintain a balance between their use. You want to um, make use of all of these three. Um, for example, you could only focus on knowing and applying, so reading about something and publishing papers, for example. But if you ignore about networking, it's going to hurt you eventually. So it's highly recommended that you try and attend conferences where you're likely to meet some interested, like-minded people, even if you are not an author of a paper yet. So just if you can, since there are so many virtual opportunities for so many of these conferences, try to attend them. Um, Not only just for knowledge, but also some amount of networking does happen in these virtual settings. And lastly, I would say just keep practicing to use these metaphorical brushes from time to time. And just emphasizing that unlike other professional careers, research is something that requires you to aggressively keep up to date with the latest knowledge in the field. And you need to know and define your problem statements inside out, and apply new techniques to solve it. So you need to meet people and foster some meaningful relationships, which can in future turn into collaborations, or you don't know, you never know what it would turn into. But it's usually very interesting how it turns out when you look back upon it in hindsight. With that, I would just conclude my presentation. Um, I know it's shorter, not like 45 minutes, but I would like to leave time for more questions. So thank you, everyone.
Thank you, Vidhi. I think there are some questions in the chat,
Okay.
which you could. So I can just read them out to you, or
Yeah,
so.
it would be helpful if you can read them.
Right. So one question is, while dealing with rejection, how do you keep yourself motivated towards your goals, irrespective of multiple rejections?
Yeah, I think I mentioned that it's having a practice mindset. You just think that, okay, I'm going to apply, but it's okay if I don't get it, because all I'm gaining is experience through this process, so that next time, next year, usually, I'll apply in a better form and shape. And that's the benefit of starting as an early career researcher, because you can afford to take these steps. I mean, early on in the career, where you can expect you are going to be rejected as compared to the third years who are applying for the same internship role.
Right. Right. Okay. So another question is, there are many fields in deep learning and so much to learn. How did you finalize on robotics and realize that this was the field to go ahead with? Because there might be many things in this domain that might interest you, and trying to learn all of them might not help you specialize in one of them.
Yeah, that's completely true. And the aspect of robotics that I'm highly interested in is learning and integrating it with the planning literature. Um, so the core idea here is that for me it was, I think it clicked with me that you can apply and see its impact, and that was the most exciting bit. But you're right that there's so many things at this point that it's very hard to decide and settle for one thing. And the best way of finding it out for yourself is just applying for opportunities, showing the willingness to put in the effort and learning about this stuff. And you can do that through internships, you can do that through these residency programs, or higher education offers so many opportunities. But yeah, just be ready to start from scratch if you are interested to explore something. Um, and if you get the right opportunity, go for it. I don't think it's too late, especially as undergraduates.
Right. Yeah. So I guess there's this exploration exploitation trade-off that you need to sort of balance.
Yeah.
Yes, the next question being, can you throw some light on the differences between an Indian PhD and one in US? PhDs in US are more coveted as they are more widely recognized. What are some key differences in a PhD at US versus somewhere else, especially in India?
I think that there are sheer more number of opportunities in some sense while doing PhD in US. Um, but more of it is, well, there are counterexamples though. Let me start with the counterexample that I know, very inspiring woman. She was a postdoc in Microsoft Research, Arpita Biswas, and she did her PhD in IISc. And later, from there, she went on for other opportunities and experiences. I think she's doing pretty great. So no matter what, wherever you are getting good guidance um, and mentorship, that is a good place to do your PhD. So I would emphasize that whether India or US, the important thing is a good relationship with your PhD advisor. And that is the most important thing. I realized that you need to be on the same page with your PhD advisor about so many things, like where you want to publish, what kind of research you want to do, what is the definition of success. You both need to agree on that. And it sounds simple, but it's so difficult that glitches like these could happen anywhere, be in India, be in US. So so um, I was somewhat confident after my master's program that I could get the opportunities in US. And I did apply to some of the PhD programs in Europe. But yeah, this application process was again with the practice mindset that if it doesn't happen, I'll apply again. Also, for applying for Indian PhDs, I imagine I would have to look through the application process in much more detail, which I'm not particularly sure of as of now. So I think, yeah, that's about all I know in comparing PhDs in US and India.
Right. Yeah, so the next question is, how do you decide if you should go for a PhD or not? If you find research interesting, but ultimately want to end up in an industry research position. So
Yeah,
yeah, sorry, go on.
that's a good question. The So PhD is not a good financial decision initially, if you think about it, because like if you do the math, you'll figure out that it's seriously not a good financial decision. You could be earning way better if that's the goal uh, in those 5 years. Um, okay, there are some cases in which PhDs get a lot more opportunities, like in terms of career growth, um, such as being research scientists or professors later on their careers. But if you look at just 5 year path, it's a bad financial decision. Um, that said, I think PhD does feel somewhat like a job in which you need to take the ownership and draft out how you're gonna work the way through it. You set your own goals that get approved by your manager or your advisor, PhD advisor. So it does feel like a job to a good extent, but with a lot less pay. Um, so many peers actually like half the population in Masters of Science in Robotics, my program that I recently graduated from, choose to go for industrial jobs, like professional jobs. They do not choose to apply for a PhD. Um, and many of them do. So it's, after all, a personal preference that do you want to go through the rigor and then spend that time at school, uh, want to continue learning new stuff, or do you want to go into the industry, get real experience? But maybe that's taking you away from the school. So it's gonna get monotonous after some point, some fear. Um, yeah, it's a debate that people keep having with themselves. But yeah, it's good to know these points and choose the lesser words of the two.
Okay. So another question that we have is, networking and making connections has been relatively easier this last year due to virtual conferences. What kind of avenues would you suggest for making connections in the absence of such events?
Um, Virtual or hybrid mode is gonna be the reality in future, I believe, and it has made connecting somewhat easier for a lot of people. Um, Earlier, I think the conferences and the opportunity to go and network in a conference was way harder because you had to apply and seek funding. Um, and there were like limited sources which would provide that sort of a funding to you. Um, so that said, I think there are some events, career fairs, events like, well, I got an opportunity to network a lot during Grace Hopper celebration. So, and then there are these smaller events that keep happening, career tech events. Um, a lot of them organized by college. And apart from that, in Bangalore, I think Microsoft Research has certain sets of events where they display the research and they talk about it. So yeah, keeping a watch out for what kind of events, tech events are happening, and all that information is available online. Try to reach out and see that if they can support you. And a lot of times they do support early researchers or early students who are interested in reading and working. So that's a great opportunity to do that. And if you feel that there are not enough opportunities in your locality or your neighborhood area, um, well, organizing online events such as these are a great way to, I feel, like connect with early career researchers or experienced professionals, professors, and industry leaders in this case.
So you said you applied at the end of second year for an internship. So did you have any projects to show them before applying? If I don't have projects, how shall I frame my application?
Um, yeah, it's harder to frame any application without having projects. And right, I mean, that was my fear as well, that there are these so good opportunities, but I do not have the right kind of projects right now that I could display here and demonstrate my evidence of skill in some sense. Um, but even then, like taking up that challenge is important, I feel. Um, Working through the steep learning curve for whatever is required, see how much you can push through it. Because imagine if you do get that opportunity, are you gonna fight for it or not? Then see how much you can fight for it. Um, and I think that's sort of an important thing. So if you believe that you can fight for it, try conveying that in your cover letter or something, that I'm really, really interested in this. Within these few short period of time, I have covered this much about this topic, and I'm looking forward to pursue this internship with you. So that's something that you can add to your projects. Determine whether the mentor or professor would find a good match with you, because they are trying to, especially my tags kind of explain this to me, that a lot of students apply, a lot of professors select, but they do not give this scholarship to everyone. Um, so wherever there's a good match that the professor has been ranked high by the student, and the professor also ranked the student high, that's a good match, and that's when they support it. So you can understand that this kind of inherent, like implicitly applies everywhere. um, and you would need to understand you applying for that opportunity versus the professor actually accepting you for this opportunity should have a good match in some sense.
Yeah. Okay. So another question is, how does one usually network at the virtual conferences slash workshops? Usually, I found them having presentations from the researchers and a short Q&A, but not any discussion sessions which are open to all. So does networking here actually mean following up with the speaker post the conference via email or something else?
Yeah, absolutely. And most people who have presented a paper would be happy to talk to you about the work if you are genuinely interested. Of course, there's a lot of noise in this whole process, like some people just mailing for give me this internship, give me this job. So it's important that you frame your email appropriately, have genuinely like if you have read their work, if you have questions about it, mail them. They will reply, not soon enough because of the conference and other deadlines, but eventually. And if you can be proactive about the conference, that also helps, because a lot of people block their time away from the regular work and they are actually present at free during that conference time. So read up the papers which will be presented, select a few of them which you think are super relevant to your work and you really want to connect with the researchers there, and make sure that you attend their talk, or the poster sessions are a venue where you can have discussions about them.
Yeah. So is in what cases should one do a master's first if the goal is to get a PhD ultimately?
Um, Doing a master's in hindsight was a very good idea, I feel. It does appear that maybe we are wasting 2 years in a master's and then we'll spend like 5 years in a PhD. Um, but at least in CMU, you have these courses which account towards your eventual PhD. So at least if you get into any of these MSR programs in CMU, or an equivalent program in Language Technologies Institute as MLT program, and you complete their course requirements, you do not have any courses, probably one course in your PhD. So that's great. If I would have chosen to go to another school, I would have to do some amount of courses, but that's all right, I guess. Um, if you think that the chances of getting into a PhD is somewhat bleak, instead of spending time working alone and trying to polish your resume or profile, it's I would advise to go for a master's, because it just puts you in a um, better bucket of people, because you have a master's degree to show as your qualification, shows your genuine interest in PhD. Um, yeah, I can see the issue with masters is that it could land you in debt. So the advice there is try to see if you can land into a research position with your advisor of choice, um, because usually for the first semester the professors would not be willing to pay you, so you might need to take a loan or show some amount of funding, have some amount of funding to support you through first 6 months. But if they realize your worth, they will support you, and if they can. um, so happens in a lot of cases. But okay, repeating this again, research is a risky business. It's high gain, high losses. Definitely not a very good financial decision, I would say. But it's something that you go into for your own interest.
Yeah. So I had a follow-up question about this. So currently, at least in India, after undergrad, you have all these um, industry opportunities. Like, I mean, there's someone who's done both of these. You have Microsoft Research Fellow, you have Google Pre-Doc program, or even some other companies like TCS and what when you are introducing this contract-based programs, which ultimately sort of train you to do research on your own. So, is it more advisable to go for these, or rather do a master's instead? If you're going to end up applying for a PhD.
So it's good to know the competition that lies ahead of you. I met another AI resident fellow who was born and brought up here. Um, and he is a brilliant person. He's still in his undergrad 4th year and as an AI resident, but he did his undergrad in Berkeley. And the competition, the level of competition here, I'm just trying to explain, is he was regretting the fact that he did not start research in his high school. And this guy has a lot of papers. There's two of his papers that I have presented myself in reading groups. So amazing work. And this it's that early that people begin. So it's crazy competition out here. So taking those pre-doctorate opportunities as well as going for masters helps you build a profile that can eventually help you get a PhD. If you that being said, do apply for PhD if you think you are having a good profile, but the competition is intensely fierce. So I don't know how to put this, but um, one another advice I would give is to try to find where AI deep learning skills could be applicable other than just machine learning masters and those things. Like you could find a niche area which interests you, could be that could really help in finding good opportunities in terms of PhD. Because otherwise, in general, ML and AI, it's a lot more competitive.
Right. So how would you compare AI residencies with typical research interns at industry or research assistantships at academic labs? Are you working on this in parallel with your PhD?
Uh, that's I think I would compare them equally. Um, in AI residencies, the perk is that you get the perks of a company, whereas research labs cannot afford to pay you that much, I guess. Um, and you get all other benefits of a company. So my experience at Microsoft Research and here at Facebook AI has been great because of these perks. Whereas the internships that I did in research labs as a research assistant was also great. It certainly feels that you have more freedom in those settings. So if you want to explore your own thing, make sure you find a good professor who supports you in that endeavor, and they can really let you do that. But in AI residencies, managers mostly drive the project. So it's good to get some guidance if you're not so sure on how to, or what is a good problem to work on. So that helps.
Right. Can confirm it's not. Okay, okay, Sanket is here as well. Um, so yeah, so another question is, this is more like a personal question. So I got an internship for data science role, but my interest lies in research in AI and robotics. So should I go for this internship? Will this internship help me in my future endeavor? I did apply for the research role in robotics, but got rejected. And my future plan is to apply for master's program. So I'm in a dilemma right now.
Yeah, I mean, you just got to think about economics right now. What's the opportunity cost? Like, if you do not take this internship, is there something that you can do better than this um, to secure a good position for your masters? Um, so one thing to remember about masters is you need letter of reference from your supervisors. Um, I would recommend doing self-driven projects for start of your research career, but if you're close to applying to your master's program, make sure you work with someone who can write strongly about you or support you in going for a master's program. And that would require like not just them supporting you strongly, but also like in the master's program should be in somewhat their field of like if it is a data science master program, their letter would hold more value. But if it's a machine learning or like a robotics master's program, you can imagine it will have somewhat less value. It would still be important, but somewhat less value. So make sure that if you can get an opportunity, that's great. If not, then this internship is also awesome, because you're eventually landing into a position where you can get a reference letter.
Right. So another question is, I still feel like I'm exploring AI field mostly and haven't yet zoned into one field since I tend to feel mainstream topics such as computer vision or NLP feel populated and vast. How long is it ideal to explore your interests, since exploration also takes time and I don't feel like applying to professors in the fields I'm exploring in since I haven't matured enough?
Oh, yeah, that fear of I haven't matured enough is something that will just stay with you unless you apply your whatever you have been learning in different fields to some projects, or apply to professors who can give you a project and you work on it based on all the knowledge that you have gained. Um, so yeah, exploration is cool. It's good. And it should just be to guide you what are the good opportunities to apply for, and what are the things that you don't want to do. So um,
Yeah. Okay, so how would one how how can one maintain their network with professors which they had earlier worked with?
mhm, yeah. So I mean, just by connecting with them, with like on and off, that helps. Sometimes it feels as if we are overburdening and taking away their precious time. Um, but you realize that they're more than happy to be there for you when you ask them about advice. So when I got my PhD results, I reached out to every one of my mentors, research internship advisors, managers, and they were happy to advise me on how to make a decision. They were curious to know what I was going to do. We just socially connected, so that was good. Um, One way to secure a letter is to apply for other opportunities. Like there are so many fellowship programs right out here. There are so many research internships, or at least Microsoft Research Fellowship required a letter to be sent as part of the application. So I remember connecting with them, requesting a letter right around the time my internship was over or got over. And that helped, like they remembered exactly what I had done. They prepared a letter for me, which I used, I mean, much later after I completed the internships as well, because it was, they strongly supported me. Um, and that's what your new recruiters are going to see. So it was useful to connect with them, make sure they understand what work you're doing. Um, and this just, it's not just a part of meaningless process, it's a skill that would help you eventually work in teams, work collaboratively. So think of it that way. Like you would want to connect with your manager eventually if your goal is to go and work with the company as a research in a research role, or you would want to connect with other peer professors who are trying to um, as you are trying if you want to go into the academic route. So I'm just trying to emphasize here that um, make sure you stay connected with your letter writers, um, and just like they just have a lot of useful advice to offer. So
Yeah. Yeah, I think we could take a couple of more questions. So, would you recommend getting a PhD to someone who already has a full-time industrial position, given that the position that the person has is already at the level that he might work on even after getting a PhD?
I'm sorry, I did not catch your last part.
So, the position that the person is currently working in, it's a pretty high-level role, and it's likely that even after getting a PhD, he'll end up at a similar position. So in that case, would going for a PhD be justified, or in what cases should he or she
That
go for it?
level, it's a very high role. So a lot of times companies support people in their endeavors for PhD. Now, at that level, PhD just becomes um, a self endeavor, I guess. I might not be the right person to answer this probably, but I've known that companies do push their top people. They think that they might go out for a PhD. They try to support them, and that's kind of best of both worlds. So you take longer to complete a PhD, but you get industrial salaries. Um, if your aim is to rise up as in the industry after a PhD.
Right. Okay, so I think we can take a last question. You mentioned that we pick up niche areas in ML and TL. I'm particularly interested in a niche area of uh, ML, which is reinforcement learning and its applications for autonomous systems. However, because RL is rather new and growing field of ML, the labs that work on it are few, and only the top institutes in the world, CME, for example, do certain kind of work in this field. How do you suggest we get a bachelor's thesis opportunity in one of these top institutes in USA when the professor's website itself says they usually don't take in students from outside the university they currently teach at?
Yeah, it's harder in US. I would agree with that. Um, and reinforcement learning is something. Uh, my God, heads crashed over a lot of it. So in the morning, I think we were discussing with another. Um, I we're discussing about offline reinforcement learning, and yeah, it just seems that a lot of the focus is now shifting. So it's research, and if it does not come out as a promising product, not a lot of labs are gonna adopt it. So that's a problem with reinforcement learning that's not really being applied to any of the products that people care about, unlike computer vision or natural language processing. Um, that's it. If you are interested in RL, look at it from other perspectives. Try to, first of all, read and know about it. There are a lot of online courses available. Then apply it probably to some self-driven projects that you can come up with, or reach out to people whose papers interest you the most. Try to figure out what you can contribute in their work. Um, so it's mostly self-driven way that you can uh, fetch an opportunity for yourself. Um, Even if like I can understand why professors just don't want to take any international students or any students outside within their college. Um, but that's something that they write for their website. If you're really interested, you can read up their work, try to follow up with genuine questions. The worst case, they'll say no, but that's okay. That in the whole process, you learn something more about reinforcement learning that you want to pursue eventually. Don't want to take any international students or any.
I'm sorry, could you still hear me?
Yes.
Okay, I think there were some connection issues on my part.
Okay.
Um, But I think, yeah, that's what we had for the questions. Thanks for joining once again, Vidhi. Thanks for your time. Um, it was a really great session. And yeah, so I think we have some time before Aaditeshwar sir joins, so we take a quick break.
Hi Aditeshwar sir. Welcome to the symposium. Hello, am I audible?
Yeah, I think you're audible.
Okay, I think Professor Seth had some, I think he's dropped off, so maybe he'll rejoin. So to everyone else who just joined us, we'll be beginning Professor Seth's, that will be our second session today. We'll just be beginning that in a couple of minutes. Um, Hello, sir. Can you hear me?
Yeah, hi. This is Adi here. Can you hear me?
Yeah. Hi, sir.
Okay,
So,
great.
all right, I can see you now.
Cool.
So I'll just give a quick introduction. So hello, everyone. We'll be beginning the second session of this morning's symposium. And today we have with us Dr. Aaditeshwar Seth. He's an associate professor at IIT Delhi, where he runs the ACD4D research group. He's also the co-founder and director of Gramvani, a social technology company using information and communication technologies for facilitating societal development. Professor Seth studies the factors impeding socio-economic development, participatory information sharing on social networks, and low-cost computer networks and ICT systems for rural areas. Systems built by Professor Seth's teams at Gramvani and IIT Delhi have been used by more than 150 development organizations in India, Africa, and Afghanistan, where they've touched more than 2 million people. Several elements of their work have also been adopted by government departments in India and have influenced the use of ICTs for development within many international organizations. Today, we're hoping to get Professor Seth's insights on how technology is deployed for social good and social development, and what role AI can play in such solutions. Just a quick note to the audience, we'd like to keep the session as interactive as possible, so feel free to put any questions you have in the chat box, or I'll be asking a few broad questions to start off with. So after a while, if you want to unmute yourself and ask, that'll be fine also. So just to start off with, Professor Seth, thank you for being here.
Yeah,
It's great to have
thanks
you.
a lot. Yeah.
Just to start off with, I recently came across the introduction to your book titled Overcoming Paradigms That Produce Disempowering Technologies, a call to technologists. It was really kind of eye-opening read, and I'm looking forward to release of the book. And I think one of the key concepts you talk about there is the alienation that has developed around technology makers, which means that they often aren't aware of the real life consequences of their solutions. I think in today's audience, we have mostly students, undergraduates and recent graduate students, and most of us are looking to use technology and specifically AI in ways to, a lot of us are interested in researching it, and ultimately ways to, we all hope that, we can create some good in society through our work. So I think it'd be great if you could maybe talk about this concept of humanism that you talk about in the book, which you say is required as an internal change within technologists and students, and I think the people who ultimately make the technology, and maybe why that is required in the first place, and how that might be required specifically for AI, which many consider really powerful technology.
Cool. Great. Thanks, Athar, for starting from what I'm trying to write in my book. Great. So I'm sure all of you are aware also, right, that while technology has been very useful, it's had such tremendous impact, right? Even, for example, during COVID, right, the rapidity with which vaccines were made. Similarly, even systems where when people were suddenly rendered out of jobs, then it was really technology that came to the rescue of making immediate cash transfers to people so that they could get some cash relief. So the government brought up many such policies and schemes to help people, right? So technology has, of course, been a game changer, right? In general, throughout of human civilization. But at the same time, we all know that it's also led to harmful outcomes as well, right? So I'm sure all of you are aware of so much of discussion and debate that goes on these days about how social media platforms have impacted democracy, for example, right? That while earlier they were largely seen as platforms which were going to strengthen democracy by giving more power to the people to voice themselves, to share information, share knowledge. But much of that narrative has been rendered suspect, right? So similarly, so many other things right, we know about Uber, and at the same time, right, we also hear about exploitation of drivers that this has created. And I mean, I can go on and on, right? I'm sure all of you are aware of so many other examples as well. So the question really that this leads to is that why does this happen? That why does, right? So all of us are well-minded technologists, right? This includes engineers, scientists, designers, right? We are all nice people in the sense that we don't want our innovations to lead to harmful outcomes, right? But even then it happens a lot, right? So the main question really was that why does this happen so frequently, and what can be done to prevent it? So so this is really where so in the book I try to deconstruct, right, different ways in which problems happen, and largely the reason why I say that this is an internal change that all of us need to make in our day-to-day practice of technology development and innovation is that very often we might we normally just think from within the technology domain itself. Very rarely do we actually even have knowledge of what will happen once these systems are put in the world. Because we can't think of everything, right? As designers, we'll think of many aspects in which things could go wrong, and we'll try to build algorithms that can improve it. So like in AI, there's a lot of focus these days on research on fairness in artificial intelligence, right? Similarly, on user interfaces, right? There are now regulations coming in that try and make sure that you're not presenting or ranking results in such a way that will persuade users to take certain actions that you want them to take and not that they would have taken otherwise. So these are spaces where behavioral economics and nudges can sometimes be used for good, but then they can also be used for harmful purposes. So the point is that the reason why we often ignore many of these things is partly we may not be aware of, we may not have thought about technology from a broader social standpoint of what happens once people start using it. And we have a lot of experiences that can help us learn, experiences from previous technologies, right? But very often in our technology courses that we do in a computer science curriculum, we normally don't look at those things, right? We normally, when we're talking about algorithms, we're actually talking about efficiency, time efficiency, space efficiency.
Right.
So those are the metrics we're looking at. But we often forget about this wider social impact. So although I've, so I'm going a bit slow just so that we're all able to get our thoughts around this point, right? So, so given this, what can be done about it, right? Now, normally you have the government coming in with certain regulations, putting in certain rules so that some of these harmful aspects are avoided, right? That as a matter of compliance, right? There are certain privacy mechanisms that you should employ if you're building a system, for example, right? Now there are increasing regulations like data protection laws and everything coming in, right? But the argument that I largely make around this is that even though regulations come in, right? Regulations often come in after the fact. Right? So technology innovation normally precedes, and then you start understanding the implications, and then you start bringing in regulations. But often by that time, the technology is too large, too widely adopted, that it becomes hard to change it or redesign it. And that is really why basically I'm saying that regulations cannot solve all the problems. Being mindful even at the design stage cannot solve all the problems because the world is complex. You can't think of all eventualities. And that is why continuous steering of technology is needed. And who steers the technology? Who builds? So right, once you put a social media system in place and now you're seeing some harmful uses of it, right? How do you react? Do you react at all? Right? Regulations might not be there in place by then. Maybe your economic incentives are not forcing you to react in certain ways. Then what is the fallback? Yeah. So this is where we say that where the fallback is actually personal ethics itself, right? Because you cannot outsource your morality. you cannot outsource your morality to regulatory institutions. That okay, I'll do whatever I want until I'm caught. Right? You can't outsource your morality to economics because incentives and largely the way economics as a field itself is structured, it relies on rational behavior and which is normally profit maximizing because that's the economic paradigm of capitalism that we live in. Right? As long as we are in capitalism, it will lead to profit maximization as a key incentive and not so much of, right? If profit maximization leads to right, moral behavior, right, capitalism is supported, but not otherwise. And over there itself, there are many complications that I go into in the book that prevent it. Right? So that is why the bottom line argument that I'm getting to after this long-winded discussion is basically that you can't run away from personal ethics. And this we need to inculcate in the school and education curriculum itself so that we're more aware of the wider social implications of our technology. There's many experiences before us, so we can learn a lot from these experiences. But we do need to be more, right? It is only personal ethics that will make us think also about how to design. Once it is designed, it will inspire us in terms of how to manage the technology. So that's the idea. And why would we do that? Why would we be more ethical in our behavior when nobody's forcing us to do that? So this is where Marx comes to the rescue. So Marx, we all know about Marxist theories from the point of how capitalism leads to exploitation and therefore systems like communism can be better. But underlying all of this is a key principle that why would that are humans more would they appreciate or are they by nature more selfish and profit maximizing sort of what capitalism does, or are they by nature more cooperative as what communism brings in? And he develops this concept of humanism. So it's called Marxist humanism. So there's many concepts of humanism. Yeah. But Marxist humanism is basically about saying that, well, you derive your satisfaction from relationships that you build with other people through production. So when you are producing something, somebody else is consuming those goods or services, then it leads to a social bond between the producer and consumer. And humans by nature want to make positive social bonds instead of negative social bonds. And when you make negative social bonds, so if your production is leading to harmful effects on others, it does hurt you in the long run. And this is what he calls alienation, that capitalist systems ultimately alienate people from one another. Because they throw ethics, they throw positive social relationships on the side. None of those matter. And yeah, that's why these things are necessary.
All right. Yeah, that was quite insightful. So I think it's good for us students to especially at least think about these ideas of ethics, which usually it's often ignored when we get bogged down in the technical aspects of the research. So I think nearly most people here are interested in using AI to build solutions and tools. So in that sense, one question connecting to our previous discussion is, what kind of dangers and pitfalls do you see in the near future that AI technologies can have? Especially, I think there is this recent trend towards AI for social good applications, where a lot of people are getting involved and a lot of people are trying to help using these technologies. So I think we all know about how AI for commercial usage can have certain negative impacts, but could you maybe talk about how we should be careful when using AI for social good, and maybe think about how to actually not alienate ourselves and just think about the theory, but also think about what the consequences of our work is having on the ground?
So one of the ways, right? So AI for social good, right? I mean, it's right, debatable how you define social good, right? See, ultimately, any technologies, if they're useful for somebody, well, they are useful, right? So in my opinion, AI for social good is not very different from any kind of technology development per se, because I mean, ultimately you can sort of define that, okay, I define social good as something that is more focused on health or nutrition or social justice. So, right, but that's more of a domain. I think it's just a syntactic aspect, right? Because in general, I mean, if any technology is helping, right, you can argue that it's still useful, right, and socially useful. So, so in general, with technology itself, and AI again is not very different from many other technologies that we've done. So the one way in which many issues do arise is that once you've deployed the technology, right, it requires continuous steering, as I was saying earlier. Right? So, and that is something that anybody who's doing AI for social good, they also have to be mindful of that. So for example, once you've learned a particular classifier, and now you see that, well, that classifier is failing for certain demographic groups and giving higher error rates, let's say, on one demographic group over another, then it is ultimately a matter of choice, right? That because now, of course, anti-discrimination laws can be used, right? But ultimately, it's a matter of choice that are you going to tweak your classifier so that it eliminates this error rate disparity, as it is called, right? So, and in the same way, so I started by saying that technologies like direct benefit transfers were very useful when it came to giving quick cash transfers, right? So Aadhaar and all of this is enabled, right? That we could transfer cash very rapidly to people. But at the same time, there were many exclusions that also happened. Exclusions that many people who are actually eligible, migrant workers, rural residents, but many of them were not able to get the cash transfers that the government supported. Many of them faced problems with getting the free ration that the government had announced. And this was happening because of many reasons. That once Aadhaar was brought in, because now this was a technology-centric system, there were many mistakes. So wrong bank accounts of people were linked with Aadhaar because of data entry errors. Sometimes their payments were rejected because of spelling mistakes in their names. And the people to whom these benefits were targeted towards are not really tech savvy, right? So you can't expect them to go to a website and to fix things, right? They need assistance from government officials, from social workers. So so in the same way, right, even with Aadhaar and so on, we can see that the technology was designed to support biometrics so that even poorly literate people could use the technology, could access it without any issue, right? They didn't need a mobile phone and like OTPs and all of that stuff to do it, right? So great. But when the technology was deployed, right, then again, it's a matter of choice by the administrators and people managing the technology that, okay, we are noticing that all of these exclusions are happening, but are we doing anything about it? Are we trying to improve our processes so that spelling mistakes don't happen, right? For example, or make it easier for people to correct their spelling mistakes, right? And again, right, technology can come to help because you know from prior accesses of people that for whom is the technology failing, for whom is it not working, and then you can try and help those specifically. Because you can look at transaction logs, you can see that, okay, it's failing for these people. Let us launch a drive so that we can re-enroll them so that they're able to get cash transfers and so on. Right? So ultimately, I think that's the key point, that designers and others can be mindful as much as they can while they're making technology. But once it is deployed, it still requires continuous steering because new problems will arise. And this is true for any technology, be it AI or be it a non-AI technology, that with this continuous steering, are you working towards making sure that whatever problems you're noticing, errors you're noticing, you're trying and fixing them, rather than say not bothering about it unless the regulations force you to do so, unless compliances force you to do so, right? So again, I mean, I'm taking that ethical standpoint over here, but yeah, right. So even with AI, that's one of the things. The second, that it requires continuous management and steering, right? I think the second thing that is a risk with AI is the agency that we start attaching to the technology, right? That we start believing that because this output was produced by an algorithm, by a machine, it is free from human biases. Yeah.
Okay.
Because then you start taking the technology as making an objective decision, right? Right. Be it right, like the use of technology in recruitment, where right, you automatically scan CVs of people and then you try and identify who are the right people that I should interview. Right now, if a human were doing it, maybe there could be some biases of the person creeping in, right? Maybe some caste biases that the person would have, and so on. That this person could shortlist people he likes, right? So the idea is that you bring technology and then you're assuming that the technology is being very objective in its output, and therefore you attach a higher agency to it. But that again is suspect, right? Because right, this is what the whole fairness in AI field has been talking about. That right, the technology, right? Machine learning is built using data that has been fed into it, but there are certain biases, entrenched biases, which are in the data itself and which reproduce. So there's a fantastic book also, Fairness in ML. It's an open source book actually, which talks about many such issues. So it's openly available. It's called Fairness in Machine Learning by Arvind Narayanan and Michael Hart and Simon Barokas. So you can just Google for it, just say Fairness in ML book. And it's very accessible, very readable. And the book talks about many, many such examples of how entrenched biases in the data get reproduced in the machine learning algorithms and which then lead to issues. So again, the point, however, is that you're ultimately, right, you're attaching a higher agency to technology as opposed to humans. So that can have even wider implications, right, beyond machine learning alone. Because then you're really losing, you're saying that machines are better than humans, and then that becomes a slippery slope. Because we know that machines require steering, machines require the right design. So, right, so ultimately, the authority that we're attaching to machines is misplaced, because ultimately it is humans who have done all that.
So there's definitely, we need to be careful. So about firstly monitoring the technologies we're deploying, and also thinking about not just ascribing carte blanche to them in terms of, okay, these technologies are the truth, but instead thinking about how they're developed and what goes into them. All right. So to kind of pivot the discussion a little, I think many of us there is always that feeling that we want to use our skill sets that we've learned through engineering college and as students, and use them in projects that can actually have impact on the ground. And a lot of times, not just kind of consumer impact that, okay, I'll build this product, a lot of people will buy it, but also the fact that it will help empower previously disadvantaged people, or will help create new economies and these kinds of things. So I think you have done a lot of work deploying technology at Gramvani and IIT Delhi, which help people on the ground, especially rural disadvantaged people. So could you maybe give us a little context about, or insights into the pipeline of such projects, how they're kind of thought up, and how you actually ideate on the solution process? And then, as you said, how do you monitor the solutions to make sure that you are kind of having a good impact on the ground?
No, great question. And the main point I'll try to get across is how ignorant we were as technologists, really, in trying to think that we could change the world. So even with Gramvani and before that, some work I had done during my PhD on providing rural internet connectivity. Right, so all of it was, of course, inspired by exactly what you're saying, that we wanted to see how we can use our skills as technologists, computer scientists, and bring some positive impact in the lives of disadvantaged communities. So if we can provide internet in remote areas, people will be able to participate online, do all sorts of things. And then with Ramvani, our idea was that there are literacy challenges. So just bringing the internet to people will not solve their problems.
Okay.
And that is why we wanted to go the route of building voice-based technologies, so that the voice becomes a common denominator that even less literate people can access. So over there, we built systems for community radio stations initially, where so community radio station is where you basically set up a small FM broadcasting tower in some rural area. There's a studio also attached to it, where people from the neighborhood can come. They can make audio programs. So these could be on folk songs. These could be agriculture advisory. These could be about what kind of work people want under NREGA. And so this audio content is made and then it is broadcast. And because it is on audio, it becomes accessible to everybody. And later on, we built an equivalent system on mobile phones. And even phones that did not require internet. Right? So through regular feature phones, what we did was that people could call into, we use IVR, interactive voice response systems, which is what you get in a call center. So in this setup, people could, through their phones, they could just place a missed call to our server. Our server would cut the call and call them back. So this was done so that it's free for them. And over this call, they could listen to audio messages. So they could listen to the first message, skip to the next message, skip to the next message, sort of like a voicemail. But they could also record their own message. They could also, like if they want to ask a question on agriculture, or they want to report some issue on corruption or some grievance on a government scheme, then they could record a message. And it's all in voice, so anybody can access. And then what we would do is we would take their messages and we take them through a moderation process as somebody reviews them. And if the content is okay, nothing objectionable, then we publish it back on the IVR. So other people can also listen to it.
So almost like a social network based on voice and being able to be used by everyone, regardless of literacy status, technology access.
Exactly. So basically a voice-based social media, participatory media platform. And so here the idea is that the content is produced locally, it's in voice, and it's also consumed locally, right? So essentially local consumption production through voice content. So while all of this was great, right from providing internet connectivity to thinking about voice-based systems for community radio and then voice-based systems for IVR. So how did we arrive at these solutions? Well, first of all, we would regularly interact with non-profits, NGOs who were working on the ground, and we would also visit communities. We would so essentially to try and understand what are the problems, and then we think of appropriate solutions. So that's the process we followed for all of these different projects. So I remember when I was doing my PhD, then I did my PhD from the University of Waterloo in Canada, and I would normally come back home each year for for a couple of weeks for vacation. And during that time, I would meet NGOs, and that really helped me understand what were the problems on the ground that people were facing. I would go on field visits with them, interact with people. So that really helped to think of what's an appropriate solution to build, right? What kind of technology should we develop? Then after that, we build the technology, and then we want to pilot it and prototype it on the ground to see if it works or not. So this is where, again, it requires strong field partners, right? So non-profits or others who are actually working on the ground, who can use your technology and who can then help try it out. Because you alone may not have access to communities, right? You may not have access to people in these communities who can regularly work with you. right? But nonprofits have been working in this space for a long time. So, so that field partnerships are very essential, and because they then help bring a lot of feedback about right what's failing in the technology or what other issues are arising. Yeah. So,
Right.
and different projects have gone through different stages. Right. So sometimes when we deploy the technology in the field, it leads to a lot of feedback about bugs or scenarios that we hadn't thought about, and then we redesign, reiterate, and put it back, right? But some of the most so when I started with saying that we really realized that how naive we were as technologists. So this was really when so when we started Gramani, we were basically a team of engineers, right? And thinking exactly like this, right? Let's build technology. We have the right field partnerships, and they'll help pilot the technology. And then once the technology is built, well, everybody will adopt it, and it will change the world. It will really bring social media, participatory media to the grassroots, and they'll be able to do wonderful things with it. But there were many challenges that we saw. So one was that with the non-profits itself, so ultimately they are the ones who are telling people how to use the technology, right? What can it do for them? Because right, we are not there all the time in the community. They are the ones guiding the people on how to use it, what to do with it. But for them also, a lot depends on their own internal capacity. Yeah, because some of them might be able to adopt technologies quickly, but some of them might take more time. So what we started realizing was that it's not as simple as we just build the technology, we've put up documentation, we put up some case studies, and now any non-profit, anybody, right, can come and use it. It's not that straightforward because they require a lot of mentoring. They require a lot of, I wouldn't say mentoring, but essentially a very close partnership where we think together, because all organizations they work in different places which have diverse issues, and that thought process has to be repeated. But how to embed technology is right. So so as we went along at Ramani, we then built teams of what we call program managers. And the main work that, other than actually managing programs, one of the main work that, and in fact, one of the main big impacts that we've also had is that we've now, over the years, we've talked to hundreds and literally with, hundreds of organizations who are using a technology. But a large part of the impact has come from helping them think through what the technology can do and how can it be embedded in their existing programs. They might be doing something on health, they might be doing something on governance, but what's the right way to think about fitting technology?
Right.
The second issue that we also learned, right, is that even though we might think that we've made a voice-based technology, it'll be right, it'll be used, and right, it's more accessible to people. But it was only when we actually went into the field and we actually saw people using it that we started realizing how existing social inequities would impact this as well. Right?
Okay.
So, for example, we saw that right, only men were using a technology, right? No women were using it.
Yeah.
And this is sort of, now if you think about it, it's sort of obvious, right? Because we know that there is what's called a digital gender divide, that women often do not have access to phones. Maybe if there's one phone in the household, the husband keeps it, the woman doesn't have it. Or even if she does, she normally gets hand-me-down old phones, broken phones. So sometimes you see, right, the numbers itself are not visible. Sometimes some buttons don't work, right? So maybe only the green and red button work to make calls and, to just pick up a call and to end the call. But they're not really able to dial numbers and so on. Also, just reaching women to tell them about the platform is also very difficult. And this is just because of patriarchal arrangements where it's hard to, right, women, there's women collectives may not exist on the ground where women meet, and you can in these meetings, you can actually approach them.
I see.
Right, with men, you'll find them at tea stalls, you'll find them in panchayat meetings, you'll find them in so many different places of congregation where you can go and you can approach them and you can tell them about these technologies, that these systems exist, and right, this platform exists and you can use it. just approaching women is harder. So we
Yeah.
had to build all sorts of different methods to do that. So now we work a lot with women self-help groups. So self-help groups are right, they're set up as financial right. So people can they make savings regularly, and then they can use these savings for different initiatives. Right, maybe somebody has a health crisis and they want to borrow loan from whatever savings they've accumulated as a group. Right, so these initiatives already exist, and then we found that approaching women through these self-help groups is one venue that we could use. But we of course had to wait because we couldn't create these groups ourselves. So in places where these groups exist, we're able to reach women, but where these groups don't exist, it's much harder.
So
similarly,
these kinds of problems were only visible when you actually deployed the technology on the ground. I see.
Exactly. Same with caste issues. So we built a setup of recruiting community volunteers who would then tell people about these systems, how they could be used. But we also started noticing that the volunteers would then bring other users who are from their same communities. And therefore, if we wanted to create a platform where marginalized groups or lower caste groups were not excluded from the technology, we had to make sure that we have a diversity of representation in our volunteer base itself.
Okay.
And this also meant that we had to identify our volunteers carefully. So now over the years, we've gotten better at it. But right, in terms of bringing in volunteers who are open, who do not have entrenched caste beliefs of themselves, because otherwise, if you have biases in your volunteer team, then those biases only get reproduced when they are working with other people. So, so I'm just giving these examples, and similarly, I mean, there are lots and lots of such cases that I can talk about. But it is only when you actually deploy the technology, when you get on the ground, that you start noticing all of this. And this is what I meant, that there are certain things which you can take care of at the design stage, right? Based on whatever you know about how the world works and so on. But there will always be surprises because the world is complex, and it is not easy to model the world in all its complexity when you're designing technology, when you're designing policies around the technology, or when you're designing regulations. And that is why it needs continuous feedback coming from the ground. It needs you to be on the ground so that you can observe and you can then steer things accordingly. Right? So things like I was mentioning, right, having diversity in volunteer teams, or figuring out how to reach women, and similarly, there's many such things. How to make sure that there's impact coming from the technology. Right, if people are raising problems about government schemes, what techniques should you adopt on the ground so that these problems are actually solved?
Right.
And right, so all that requires you to be on the ground, and that's really the main learning. So the Gramvani team now, we're almost more than 70 people. But the technology team is a small team. Technology is right. There's just about we just have about 15 people on the technology, but we have a whole field team which does field mobilization, committee mobilization. We have a content team that thinks about how to create creative content, and it manages editorial policies on content submitted by people. Because right, these editorial policies are something also that we had to evolve carefully to make sure that diverse voices are encouraged on the platform. And right, program managers, like I talked about earlier, who can work with our partners and really think through right, what's the right way to embed technology in their operations and their functioning.
Okay. So it feels that this is a really complex process, and there's a lot of humans involved. And there's quite an important reason that you are impacting people's lives, and you want to make sure that each stage is handled by a person who knows the context and the surroundings of that area or that specific community. So I was just kind of trying to see where can AI kind of fit into these sorts of pipelines and solutions, and is there do you think in like recently developed AI technologies which have been really popular in commercial solutions, do you think there's any opportunity to use them here to maybe accelerate these solutions, scale them up, or even to introduce new kinds of solutions that weren't possible before?
Yeah, no, absolutely. So in fact, some of the areas where we've been applying more and more of AI, a lot of it is in bringing more operational efficiency. So things like when people record a message.
Okay.
Right now, until recently, we were manually processing all of it. So we had a team of moderators who would listen to these messages and figure out which ones to publish, which ones to reject, and so on. But now we're automating that process. So we're automatically identifying content which is very noisy, and then give an immediate response to the user that please re-record from a less noisy environment. Similarly, we're building automated question answering systems.
Right.
That until now, the way question answering would work is that people would ask the question, and then the moderators would listen to it offline, right? So not instantly, and then they would determine that do we have an answer for this question in our database? That did somebody ask a similar question earlier? And in that case, we push that answer to the person, or otherwise we put up this question to an expert. Could be in agriculture, could be in health, right? So there are different partners that we work with, and they then provide an answer. But now we're using machine learning over here, that once we have a database of questions and answers, right? So once you have a database, you can think of it as a FAQ database, frequently asked questions database. So now when somebody asks a question, we use speech recognition APIs to, in real time, get the transcription. And then using this transcription, we pull out the relevant answer from the FAQ database. It's called fact retrieval. And we can play that answer instantly, right? So now, rather than having to go through an offline process, we're now immediately able to provide an answer. Similarly, we're trying to improve navigation by using something like a voice bot based interaction setup. Rather than on IVR, until now, people had to press buttons to navigate.
I see.
So if they had to, I mean, it's not as clunky. But so when people call, they can listen to a list of messages that are active at that time. But if they want, they can go to a menu and they can choose a theme that for the latest in agriculture, press 1, for the latest in health, press 2, and so on, right? So there are some channels that we have. But now we're trying to build a voice bot based interaction, so that when a person calls, they can just speak, hey, I want to hear something in health, or I have this question, and then we're able to pull out those answers automatically. So that's one place definitely where we're using a lot of technology, a lot of AI based things in speech recognition, and then. But there's a lot of scope, of course. There's a lot of scope for many other problems. So, like I mentioned about how people may not be very good at using phones, or their phones might be broken and they're not able to dial numbers properly. And therefore, if we have phone numbers in advance of people, and if we know that okay, this is at this phone number there is a family with a 6-month-old baby, or this is a family who has a child who is 2 years old. And then we can also push targeted messages towards them about could be vaccination updates that we want to send, which vaccine to get when, or could be some information about nutrition. But it's hard to, when people are not very tech savvy or they can't use the phones properly, and it's hard to get that information.
I see.
So we have, we're using, and on the ground, also the health workers may not be tech savvy themselves. So we can't expect that they'll have smartphones and they can provide us with a list of phone numbers and all of this information. So what we did is a very low tech solution that we built paper forms, right? Just like a regular form that you have, which you fill, right, when you're getting a mobile connection, for example, right? So it's just a simple form where the people can write in phone numbers and then use OMR, optical mark recognition, to basically color that. Is there a child below 6 months? Is there a child below 2 years? Is there a child, right, below 6 years, and so on? And we then use optical character recognition to recognize these handwritten digits and optical marks. So, right, so the health workers, they basically just fill out these paper forms, and then they deposit them in their office, and somebody just takes a photograph of these forms with their smartphones, right? And we then take these photographs and we apply computer vision techniques to then get phone numbers and any other metadata about those phone numbers. And then we can then start pushing calls to people, right? So these are just some examples, right, of how we need to understand what are the challenges on the ground and then think of what's the appropriate technology to build, which people can use easily also, and it will help us do some useful things. Yeah.
Okay. So AI seems like a good tool to be able to scale these projects in places where enough volunteers or NGOs and these kinds of things may not be available. There might not be human resources there. So okay, that's definitely interesting. So I think how can students, undergraduates especially, who want to help out in such efforts, how can they kind of maybe go about deploying their own solutions? So people, there's a lot of people want to have startups or create get initiatives going. So how can they do that, or how can they maybe help out existing initiatives using their skill sets of programming or knowledge of AI and these kinds of things?
Yeah. No, I think it really has to start from reaching out to non-profits and NGOs and others who are actually working on the ground. Yeah. So because we can't think of solutions just sitting in the lab and reading about problems in the newspapers, right? Newspapers are good. Newspapers only talk about problems, right? That's largely what news ends up being. So newspapers are good to understand problems, but to really, it's not adequate to think, use that to really understand what's the right tool to build. So I think it has to start from maybe start visiting NGOs in the neighborhood, non-profits who are working, right? India is very interesting because, right, we have poverty just about anywhere that we want to see, right next to tall buildings, right? You have slums, right, and you can travel a bit outside the city into rural areas, and very quickly you'll see how the environment changes and how the whole setup is very different. So I think the first step really should be to start interacting more and understand from people who are working on the ground about what are the problems, right? Observe for your own, and I think that will lead to ideas. Right. So that's a more appropriate way of going about it, rather than thinking that I know how to do this, now let me go and see where can I apply my solution. Right. So it's like a hammer in search of a nail, but rather we need to find the nails and then figure out what's the right hammer for these.
I see. So it's much more problem oriented, that you try to first have to identify these things. So one of the I think one of the reasons why, or maybe this is probably a wrong way to put it, but a lot of students especially are interested in deploying solutions, especially in more of the commercial side, because it's really easy to scale up and really easy to see, I have this many new users of my product, I have this much more revenue coming in. And with commercial products, you can scale up, especially internet and AI-based solutions. Scaling up has become almost trivial now. And you see a lot of these businesses, especially in the education technology sector, social media. So it seems that it is fundamentally difficult to do this when you want to deploy solutions on the ground and to help people. So are there any kind of things that can be done, to facilitate this scaling up process, to be able to do this much faster, or maybe have solutions which can which can be deployed much more quickly than having to go through so many organizations and people? Or is it just fundamentally that this is a hard problem which needs a lot of people involved?
I think the answer is more complex. And the paradigms are also changing. So I think that there's two parts I think that come to mind. One is that certain technologies or certain innovations become easy to scale because they're easy to adopt. they're probably easy to adopt, right? So that raises the question that who finds it easy to adopt? Now, in the what you're calling commercial applications are typically those which end up being targeted towards the elite people, right? Who have access to smartphones or the internet. They've been to schools. Their education is good. They probably also have prior experience with using technology. So naturally, it will be more easy for them to adopt any new technology.
Okay.
Yeah. And then you will get those scalability effects.
Yeah.
And then that will lead to a conclusion that, these kind of solutions, right? You can, right, quote unquote, what you're calling commercial solutions, are easy to scale, right? But the point is that they were easy to scale because they were meant for people who could adopt them quickly. Yeah? And that is why they were easy to scale. But if you look at then building technologies for people who do not have that prior experience, and therefore they will not be able to adopt it easily. And that is why, for example, in our case, we had to work with volunteers who can train people, who can demonstrate how the system works to people, right? So there's a whole, right, a human machinery that had to be set up to augment the technology, right? So that it becomes more easy to adopt, right? So, so I think that's one aspect that needs consideration, right? That I think it's not correct to say that some technology, right? So commercial things are easier to scale. I think it's more about who is it meant for. For certain users, it's easy to scale. For certain users, it's not. And in this case, if we continue building more and more such technologies, it will only increase inequality, right? Because right, those of us who are able to use things, right, we'll be able to do many more things with those tools. And but we've left behind, and the gap is increasing between those who could not sort of. So this is where, I mean, there's a lot of debate about digital divide and all of those things, right? I think the second aspect also is that with this, right, what's called the platform economy, some of these things are changing also, right? Because platforms are actually providing a space where if there is a common minimum infrastructure available to everybody, then it becomes easy to build innovations for people, right? So, so I think some of that is good, that it makes it easier for innovations to reach people, right? But the dangers in this also is that some of these innovations may not be very well-minded. They might be profit-oriented, which are looking at extracting value from potential consumers, and not so much as what is actually going to benefit the people. So there's two sides to the coin. That platforms make it easier to reach people and help improve the adoption, make the adoption faster. But at the same time, the motivation behind these innovations may not always be good. So there needs to be some checks and balances. That what are these innovations being put on the platforms? Yeah.
Okay. Yeah. So yeah, I see. All right. I think we'll take one last question.
Sure.
So an audience member is asking, what are some examples of applications of AI that can be used to help people out on a more local scale? Some things that individuals with basic knowledge of AI ML can deploy on their own.
Something that people can learn to deploy on their own. So, so I think this does connect a little with what I was saying, that in local environments you need to find champions, right? Some people who are able to understand the technology quickly, and they're able to do interesting things with it for specific use cases. So, right, so some particular thing could be used in different ways by different people, in different communities. But you need some champions, you need some community leaders who can take this technology and do clever things with it.
Okay.
For their own local communities. I think maybe that's what the question is going to ask. Is trying to ask. And there's a name also for this process. It's called communitization of technology. that how do you build technology so that different communities can customize them for their own local needs. So I'm sorry, I'm not able to exactly think of some examples, but I mean things like right, even I mean you can think of Alexa, for example. Right now, what these tools are doing is that they're making it easier for people to innovate, to build, right, what are known as Alexa skills, for example. Right now, a farmer. So I'm not sort of suggesting that farmers use Alexa, but I'm just like creating a hypothetical use case that that let's say such technology. And now there are some open source equivalents also. So Google has the voice kit, for example, which is like an open source Alexa. Now, right, these are done in such a way that using no code, right, no code technologies or low code technologies, right, with low amount of coding skills, people can think of clever use cases that might be relevant in the community. So some community which is doing agriculture could think of using this to, right, build a simple system where people can query mandi prices, right? Or somebody else could think of this in a different way, right? So I was talking about giving health information to mothers, right? So maybe another such voice-based system where people can just ask a question and now doctors in a particular area are able to localize it in their own language if they have this Google Voice Kit with them, right? So so I think the characteristic that you need to look for is that that there is that okay, it's a platform, but now can somebody quickly make some applications on it, and so that's where you probably some of these voice toolkits. That's one example. Similarly, data collection kits for data collection, right, where the essential thing is available, but different people can customize it in their own local setups. Those can be some examples. But yeah, there's I think there's a lot more that we can think about, and I think it's a good direction that right, which can make access to these technologies sort of more democratic, so that people can innovate and build upon it on their own.
Okay, so there seems to be two main kind of uses of AI that pop out to me, at least. Is one is scaling up the solutions you're deploying on the ground, and another is technologies like voice processing, which really lower the barrier to people using your solutions in the first place. So yeah, I think that there is a lot of that can be done.
Yeah. No, absolutely. There's a very rich space for innovation. Right, there's a lot that can be done. Right, technology is always improving. But yeah, just to reiterate some of the messages. Right, one is that we need to understand the needs, and we can understand the needs only by getting on the ground ourselves, by talking to the right people and everything. And I think the second point is that it requires us to be continuously engaged with the innovation so that we can continuously keep steering it.
Right.
Because, and that's where ethics comes into the picture as well, because that can give us those guardrails in terms of what to emphasize, what not to miss out. Because new problems will keep arising and we should react to those.
All right. I think that that's all the time we have for today. Thank you, Aaditeshwar sir, for joining and giving up your valuable time. I think we've all gained a lot of insights and learn about stuff usually that we aren't exposed to as scientists and engineers. So thank you for taking out the time.
Yeah, no, thanks a lot for having me. I really loved the conversation. Great.
Me too.
Very
Thank you,
great
sir.
questions. And yeah, it was fantastic. All right, thanks everybody. And yeah, all the best for everything.
All right, sir.
Yeah.
So we'll be having our third and final talk for this morning, but from Sanket. I think Sanket is here. Yeah. Sorry about kind of. I guess we overran a little, but hopefully. So I think Vedant will be giving.
That was a very important discussion to have, and I think it's something which we often overlook as folks who are more focused on the technical nitty-gritties of things. But yes, These issues are more pressing nowadays, and it's good that young researchers are being exposed to these sorts of ideas.
Right. Okay, so I'll quickly give Sanket's introduction. So Sanket is currently a third year PhD student in computer science at Stanford, and he's a part of medical AI and computer vision lab. And he's working under the supervision of Professor Serena Young, which I'm sure a lot of people might know about from her courses on YouTube. Sanket's current research is focused on computer vision and deep learning and using it for cellular image to study the impact of neurodegenerative and viral diseases on molecular machinery of the cell. So Sanket is a BITS Goa alum and graduated in 2017, where he worked on similar things, but ranging from computational genomics and proteomics and to parallel computing. So welcome, Sanket. I know it's pretty late over there, so thanks for it.
Yeah, no, happy to be here.
Okay, I think we could start with the talk.
Okay, excellent. Let me just share my screen. Can you see my screen?
Yep.
Awesome, great. So I added in my ID number after listening to Vidhi's excellent talk. I wish I had someone like her to give me that talk when I was an undergraduate. I could definitely have benefited a lot from it. And you will see that my journey in AI was less of a planned thing and more of a sort of random walk guided by a very strong instinct. But yeah, let's get into that. So yeah, where do we begin? We begin with an outline. I'll talk briefly about 3 phases of my journey. First is like what I was doing at BITS.
So Sanket, sorry to interrupt, but I think there seems something wrong with the presentation. Could you try representing? Because you can see dark patches for some reason.
You can see dark patches. Hold on. I was stopped. Let me share again. I'll change the view a little bit, just a minute.
Yep.
Can you see this?
Yeah, I think the problem is still there, but it's fine since it's not covering up the content. So you could go ahead.
Okay, I mean, what exactly is being covered up? Like,
so I mean, it's towards the right of all the points. So there's like a black rectangle.
Yeah, that's the Zoom window, which has been, yeah, I can see if I can move that a little bit. Better?
It's the same, but I think it's fine.
There's another window, I think, in the middle, a little bit to the right of the middle of your screen. There's a large rectangular patch there, which is, I think, the main.
That is on. Ah, this one.
Yeah, much better.
Yeah, it's much better.
Ah, perfect. Yeah, I got rid of it. Thanks. So are we good to go?
Yep.
Excellent. Yeah, so I'll just break this up into 3 parts. My time at BITS, what I was doing after BITS and before I joined Stanford, then brief overview of what I was doing at Stanford. We'll rewind a little bit, see what mistakes I made along the way. I think that will be particularly beneficial for new AI enthusiasts so that they don't repeat the mistakes which I made. And then I'll also maybe discuss a little bit about what I did right, and then just sum that up into some advice for aspiring AI researchers such as yourselves. Let's get into it. We will start actually a little bit before BITS and give you an idea of where I'm coming from. So when I was a kid, I saw the movie Transformers back in 2007, and I thought it was absolutely amazing. And why not? They're so cool, obviously. And I was like, hey, these are robots which are really, really intelligent, almost like, beyond human level intelligence. So it would be cool to maybe do something in that line. And it's not like I thought immediately, okay, I want to do a PhD in AI. It was more like, yeah, this is fascinating. So as time went on, I developed an interest in electronics. I bought a whole bunch of like analog stuff and, started prototyping tiny circuits. This was like maybe, 9th, 10th class, something like that. But then, we start preparing for competitive exams, and then we see stuff like this. And I was like, nope, it's too tough for me. So yeah, I gave up on electronics back then. And then I moved over to something which was kind of simpler to me. I took CS as a elective thing in 11th and 12th. It seemed fairly straightforward and intuitive to me. So I was like, when I was, trying to pick a branch after giving BitSat, it was kind of like a no-brainer. Like, yeah, I have done a little bit of CS. It's easy. I like it. Why not go for it? So I steered clear of electronics. I think that was a great decision. As EE folks will know. Sorry about that. But yeah. So anyway, let's get to the main stuff, what I was doing at BITS. So very early on, I think in the first month of college, this company called Inventron Robotics came to college. They were like a fledgling startup, which had started up just a year earlier in 2012. And they conducted a workshop at BITS, which was basically, using the Raspberry Pi. This is the initial prototype version of the Raspberry Pi, which we used. It was very different from what it looks like today. And Arduino for robotics. And so this basically launched an interest into building robots for me, because if we go back to my earlier slide, which was the Transformers thing, that sort of inspiration carried on, and I was like, hey, now I actually have the tools to build robots. Maybe not as smart, but hey, it's something. And so I built something which looked like this. Is not exactly what I built because it was a long time ago and I don't have any photos, unfortunately. But it had a sort of camera on the front. You could see things. And the cool thing was it was actually gesture controlled. So you could, use your laptop's webcam to, look at your hand gestures and, wave your hand around here, there, everywhere. And yeah, you could control it that way remotely through your laptop, which was pretty fun. And then I created this random prototype for Inventron because, this was all in my first year, by the way, just all in my first year because I thought it was cool. So the idea was basically you can play NFS using a ruler. The way it worked was you had like this green sticker on your ruler and your laptop's webcam would pick that up and use that kind of like a steering wheel. So this was just me totally exploring very randomly. I thought, hey, this is a fascinating field. I really like the idea that you can actually make machines see with code. And so I just ran with it. I just kept on exploring. It was not driven by anything other than, my interest. And so I wanted to, explore some more applications. So here's something else which I came up with in my first year. Let's see if this video plays. I don't think you can hear that. Can you?
No, it's not audible.
Yeah, I think the audio was probably not shared, but anyway, the audio is not important. It's basically an example of a smart pause feature. So the way it works is that if you turn and face the screen, the webcam actually detects your face and then it starts playing the video. And then if you turn away, it detects that you're not looking at the screen and then automatically the video pauses. So you can see now that I'm looking at the screen, the video is playing. And then even in a bit, I'll turn to the other side and then you can see that the video pauses automatically. So it's a very, very simple system built using a face detector from OpenCV. So this was, again, first year, just me randomly messing around, trying to figure things out. Let's see. Yeah. So now I want to dig a little bit deeper into the fundamentals of machine learning. And so, back then, I think there were like these Coursera things which were launched for the first time by Andrew. It was his kind of watered down version of CS229, which is the machine learning course here at Stanford. Unfortunately, I found the introduction extremely dull because it was talking about things like, basic operations on matrices, like how do you add them, how do you multiply them. I tuned out. I found it was just more productive to look straight at library documentation, things like OpenCV, scikit-learn. All this was what I did in my first summer as an undergrad. And then I got my first big opportunity to do, actual proper research in my second year. So there were a few people at Stanford and UCSC who wanted to, try doing this sort of crowd research pilot program. And the idea here was that, because there's like a lot of folks in places like India who maybe are not at, top research universities, to give them an exposure to research so that, they have something to build off of. And so they had like an open call to, students across India to maybe, come on board with this program. And I signed up, and we worked on a very simple computer vision project, which was basically how do you get humans and AI to collaborate when it comes to prediction tasks. So the way it works is that computers are very fast; they're next to no cost when it comes to doing inference, but they're not always accurate. So how can you take these initial predictions from a computer and use a very limited human budget to maybe correct some of the predictions, because you cannot afford to manually correct all of them. So how do you intelligently choose which ones of those you actually try and improve? So we showed that if you do a particular thing, then you can choose things in such a way that with a limited budget you get like a 63% time reduction, and in to reach a certain accuracy level in these collaborative kind of scenarios. So this was towards the second half of my second year, where I actually got started with like proper research. But this was my last computer vision project. This was back in 2015. I put a pause on computer vision, and I took it up again this year in 2021. I'll come to that in a bit. I took a little bit of a detour in my third year to actually explore high performance computing. So I was very interested in how you can use GPUs to accelerate things like deep learning. So I wanted to get familiar with the internals of that, which was basically how do you program GPUs to do things in parallel really fast. And so I worked with Professor Shantanu Sarkar at BitScoa, who had like, he was setting up this cluster called Kosambi. He got a few new nodes which had GPUs in them. And so we did a bunch of interesting research, some couple of workshop things, I think. I don't really exactly recall, but then there was like a decent-ish conference paper which we managed to publish after a while. We basically took one of NVIDIA's existing libraries called Thrust. We changed it around a little bit to make it faster. So that was an interesting project, which actually gave me insight into the sort of like, the technical details of how do you implement things on GPUs to make them faster, which, is very important if you're doing any kind of deep learning, if you have an appreciation of how things work at the hardware level. But I'll be focusing the bulk of my research at BITS on computational biology. This was research which I did with Professor Ravi Prasadaduri. So my work with Ravi started off in my second year. We were just exploring different ideas, and then it really picked up in my third year, final year, and we actually continued working after that as well. And now you may notice that he's a professor in the biological sciences department. You would be wondering, why is a CS guy working with a bioprofessor when he wants to do ML? And the simple answer to that question was, this was back in 2014. There was literally no CS faculty at BitScoa who was doing ML and AI. So I had no one to go to. And then one of my seniors from the CS department, he put up a post on Facebook saying, hey, Ravi's looking for students to do ML. And the CS people, being CS people, were like, you bio, we are not doing that. And I was like, yeah, let's see. Let's give it a shot. And turns out that was the best decision of my life, that one moment where I decided to knock on Ravi's door. And so we worked on an interesting problem called predicting RNA-protein interactions. This is important for a number of biological reasons, which I will not get into, but briefly you can see in this figure on the left, the purple thingy is a protein, and then this colorful thing is an RNA, and this RNA basically binds to the protein. On the right, you can see a view of what the RNA kind of looks like in a flat 2D kind of view. And the goal here is basically to try and predict how the RNA is going to bind to the protein, because this influences a number of cellular processes. This looks cute. Now look at this. This is a tangled mess, is it not? This is basically a ribosome. It's a macromolecular complex which consists of a whole bunch of proteins and RNA, as you can see, and this is actually responsible for translating mRNA into proteins. So mRNA has been in the news a lot lately because of COVID vaccines. So this thing inside your cells is what is actually responsible for reading the mRNA from the vaccine molecules and translating that into the spike protein, which your body's immune system then learns to recognize. We looked at using more classical methods here rather than deep learning. So this was basically a KMR kind of representation with XGBoost. And this finally ended up in my undergraduate thesis, where I used a mixture of XGBoost and some deep learning to do this kind of prediction. And yeah, this was kind of like, my biggest undergraduate research achievement, I would say. So yeah, that I did non-campus thesis, as you can see with Ravi, because I'd been working with him since second year. So it just made sense to continue with him for, my thesis in my 4-1. And that is the conclusion there. So what happened next? Well, I graduated. Fun fact, I actually graduated early, 1 semester in advance. So that's why my degree says here that, 20th day of March. So I graduated in 7 semesters. I had like my entire 4-2 semester free. I had, nothing to do. So I did an internship at TCS Innovation Labs. Again, thanks to Ashwin, who was, collaborating with Ravi on some bio stuff. And so Ashwin randomly calls me and he's like, yo, Sanket, do you want to work with these cool folks at TCS? They're doing like deep learning for genomics and stuff. And I was like, sure, why not? It's not like I have anything else on my plate, and it sounds like it could be fun. So I was like, cool, let's go for it. So at TCS, I worked on problems in computational genomics. So one problem which I worked on was this thing called transcription factor binding site prediction. That's a mouthful and really hard to say. But basically, it's a genomics classification problem where you're trying to predict if a given transcription factor binds to a part of your DNA. So transcription factors actually regulate whether a gene is expressed or not. That's a high level kind of explanation. So it was like a more gentle introduction to deep learning for genomics, which was a new field for me. Then we worked on deep learning for gene splicing. So in gene splicing, you have this thing called an intron, which needs to be removed, and then the exons get stuck together. And so often what happens is that this splicing process has errors, and then you get products in the final spliced mRNA, which are not what they're supposed to be due to these splicing errors. And then the resulting protein, which is translated from this mRNA, is mutated and it doesn't do what it's supposed to do. So I focused on building deep learning models, which could actually, analyze this sort of data in a sort of multitask fashion. And, the goal here was not just to make predictions, but to actually understand what is going on. So this project focused more on interpretation of these models to see what they were actually looking at. And so we saw some very interesting results that actually corroborated some biological hypotheses which were already there, and that helped us gain a measure of confidence in the model that yes, it is looking at features which we know from the biological literature to be relevant to this particular problem, and not being trained on some weird noise artifact or something, which would mean that maybe it's sort of overfitting and not paying attention to what it's actually supposed to be. This work was presented at the annual gathering of the American Society for Human Genetics in 2018 in San Diego. So we won a award like thingy for reviewer's choice or something. I think it was like in the top 10% of posters. It was a fun poster, and then a more in-depth paper was published a while later in a conference. So yeah, that was pretty productive, I would say, the whole experience. I took a slight detour in my life after TCS. This was in September of 2017, like just after 4 years after I joined BITS and after my internship at TCS. Again, I had nothing much planned. So again, Ashwin calls me. He's like, "Do you want to work at a hedge fund, Sanket? Do you want to do ML for them and predict how prices change or something?" And I was like, "Sure, why not?" Because I didn't have anything else planned. And so I interned briefly at a hedge fund until the end of 2017. And they invited me after that to their HQ, which is in the city of Oxford in the UK. It's a lovely city, by the way. And they offered me a full-time position at the office. And along with that, they were offering to support my PhD if I were to apply to Oxford University. It was a great opportunity, but sadly it didn't work out. We'll get into why later. And so, yeah, after that, I was like, let me just focus on my bio research. So I had free time on my hands. I thought I'll, try and do some more research with Ravi and Ashwin. So we worked on this interesting problem where we're trying to use transfer learning for proteomics to see that, if you have like a large data set with protein structures, can you learn some domain knowledge and then extract those useful learned features and then use them for other related prediction tasks, possibly even using different classifiers like, like a random forest, which are like really fast to train, but don't learn, really deep features. So you have fusing the advantages of learning these deep representations from neural networks with the speed and efficiency of random forest for inference. And that ended up as another paper, but it got published a little later, as you can see, 2020, kind of late, even though this work was done mostly in 2018. And then I applied for a PhD, and yeah, I got into Stanford for a CS PhD. This was back in February of 2019. Yeah, it took a while, but I got in. I was very happy. I was ecstatic. They invited me for an admit weekend in March of 2019 to, come to campus, to see the place, to chill with other PhD admits, talk to them, talk to profs, see what research is going on. And that's what I did. And I was like, yep, this is a great place. I'm definitely coming here. So I came here. I worked with a bunch of different people. It wasn't such a great match. And then finally, I joined this medical AI and computer vision lab, which is headed by Professor Serena Young. She's amazing. And I decided to, do computer vision stuff instead of genomics and proteomics. It was a bit of a shift for me, but as you may recall, I had previously done computer vision stuff back in 2015, so I had to pick it up again after 6 years. But it was fun, and I think I'm very happy now in this new lab because my advisor is amazing, my lab members are amazing, and they're working on all these really cool problems, which is basically, understanding, using computer vision to understand human behavior and then also human anatomy, and then at the cellular level, the cell biology that's going on. So I actually work at the subcellular level where we use computer vision to look at things called tomograms. So tomograms are basically 3D volumes of parts inside the cell, which our collaborators are able to image. And because of this sort of 3D volumetric imaging that we get, we can segment all these things which are inside. So these are some preliminary results which I got just last week. I thought I'll just throw them in. I don't want to say too much about this project because this is all very new and we're still working on it, but it has massive implications in things like, even studying how COVID works, how COVID vaccines work at the molecular level. So I won't talk too much about that, but moving on. I'm also currently teaching a class with Serena and James on AI for healthcare. So if that is a topic which you think is interesting, get in touch with me and I can at least share the slides with you. So yeah, fun class. It's a lot of fun TAing that. And I'm also looking maybe into future in industry where people are doing cool computer vision stuff, like Tesla, for instance, with the self-driving autonomous vehicles. So I had the good fortune of being invited to Tesla's AI Day, which was held a couple of months back in August, where I got to see all the cool AI stuff that they're doing, listen to Andrika Pathi's presentation on how they're actually building these models, very complex models which are deployed on their vehicles, and listen to Elon introduce this humanoid robot which looked pretty cool, and hear him talk about that was a fun experience. So I might look into a future in industry after my PhD is done. So that's present day. We're all caught up. Let's slowly rewind and see what I did wrong. And I think this is the part which will actually be somewhat useful for early stage AI researchers. Yeah, first mistake was my academics. I was not an academically gifted student. I was an outstandingly mediocre student. And the reason for that was I did not pay attention in class. I did not attend class. I basically had like an overall attendance of around 5% in bits, which was a result of the no attendance policy. And as a result, I was left to my own devices, which was good and bad in a way. Bad because I didn't focus on anything academic related. And so my time was largely spent doing whatever I wanted. Some of it was spent exploring AI, computer vision, parallel programming, all that good stuff, but a large chunk of it was just spent in watching random TV shows, movies, day in, day out. And this definitely had its impact on me because having a low GPA in a lot of ways closes a lot of opportunities for you, and you have to work very, very hard to overcome that. So if I had been like a nice 9-pointer, 9.5-pointer, then things would have been, much better in a way. Because, for instance, let's say you're applying for an internship like MyTax or DART, you need to have like an insanely high CGPA as well for that, in addition to having good matches and everything like what Vidhi mentioned. I was nowhere close to that. So, I missed out on a lot of opportunities. And there's a bit of a hurdle when you're applying for higher studies as well. And my second mistake was that I did not plan anything properly. I was driven purely by my interests in a way that's good. But I just took things one day at a time. And then I let life take me wherever it wanted to take me instead of having a concrete plan. And so what I did wrong, to be more precise, was that I decided I didn't want to sit for placements because I wanted to do a PhD. But then my fourth year, when I was just thinking of applying for a PhD, I didn't apply for a PhD. I felt I was not ready. So I didn't sit for placements. I didn't apply for a PhD, and I graduated early. So at the end of my 4-1, I was literally jobless. I had nothing to do. I didn't know what I would do with myself. And so I went back to BITS to work with Ravi and Ashwin for a couple of months on that transfer learning paper. And so even after graduating, I didn't actively seek opportunities. It was just my good fortune that Ashwin was kind enough to send opportunities my way. First with the TCS internship, and then with the hedge fund thing, which he sent my way. And that didn't work out. We'll get to that in a bit. And so when that didn't work out, I didn't actively seek any alternative opportunities. I was like, nope, I'm going to sit at home. I'm just going to try and do a little bit of research on my own. I give up. That was not a great attitude to have, and you'll see why. And the price for that, well, I ended up broke. And fortunately, I had a supportive family, and fortunately, I had the luxury of being able to be broke. But when everyone from your batch graduates with a nice fancy CS degree and starts earning pots of money in industry, and you're sitting alone at home with no money in the bank, that's not a great feeling. And so, yeah, no, never actually had a proper job in the 2 years that I took as a gap between BITS and Stanford. And the hedge fund was very promising because that was going to pay me a lot of money. But there were issues with getting a work visa. And they made me an offer in early 2018, a full-time offer. And halfway through 2018, they were like, yeah, actually, there's been a glitch with the paperwork. So we'll have to put this on hold for now. And so I didn't know what to do with myself. I was doing a little bit of research, wrapping up my thesis and all that. The thesis eventually got transformed into a full paper, which was published in Nature Scientific Reports, which is pretty good. So I was not being completely unproductive, but I would say that the time was not fully utilized. And so as a result, I decided to just directly apply for a PhD in the end of 2018 for 2019 intake. And so officially from that period of 2018 Jan to September 2019, when my PhD started at Stanford, I was unemployed, doing just random things. And a lot of this is because I have extreme sensitivity to rejection, not just professionally, but personally as well. And this kind of ties into what Vidhi said. And, so I think someone asked a question about how do you overcome rejection? I don't know, I'm working on it. But this led to a lot of issues. And so don't be like me, be better than me is my advice. So because I was afraid of rejection, I didn't apply for research interns. I put in an application for my tax just as a moonshot, but for DART, for Viterbi, for all the other ones, for things like MSR, I was like, no, I'm not going to do it because I know they'll reject me. I didn't apply for summer internships. As you know, early in your third year, a whole bunch of companies come to campus and they hold these tests for summer internships for the summer after your third year. So many companies came. I was like, no, I'm not going to sit for the coding test. It's not that I can't code, I can somewhat, but I was just afraid that they would reject me. And so I didn't apply. It was just the easiest solution. You just avoid it. They can't reject you if you don't apply, right? That was like my 200 IQ level logic. And as a result, again, afraid to apply for off-campus theses. So I didn't send out any mails. I was like, hey, I'm doing research on campus. I have a project. Let me go with it. In hindsight, that turned out well, but I think it would have been very productive for me to wrap up my on-campus research quickly and maybe get some international exposure by going to another lab. And so, in the middle, I didn't apply for jobs when I was unemployed. I was like, what's the point? I don't need money. The job is not going to help me with my PhD application, so I'm not going to apply. Whereas, I probably should have applied and actually done something productive in the time which I had. I didn't do it. So rejection sensitivity can really screw you over. So my advice to you is it's okay to be rejected. It's not the end of the world. Learn to live with it. And that's what I tell myself, or at least that's what I'm trying to teach myself, because I have a long way to go to making progress on this. And all this led to my mental health going down the drain, because life was clearly not working out the way I had imagined it might. And so I spiraled into a deep depression, and there were issues with my personal life as well. And I did not seek help. That is, I think, the biggest mistake which I made. This happens to people, but I did not seek help. I kept everything to myself. I kept my sorrows to myself. I kept my failures to myself. And it just led to an ever increasing spiral where, I went totally out of control, and I did not end up doing anything productive simply because my mind was not in the frame where, it can do productive things. And so things which should have taken maybe a month end up taking 12 months. So that's why there was a delay in publishing some of my research, because I simply wasn't up to the task of writing code and getting experimental results. So if you're in the same boat, I would say that you should always seek help. Do not keep things to yourself. And I did do a couple of things right. I feel the main thing which I did right was I did a lot of research. And that's really important. If you're planning to apply for a PhD, you need to have, what the admissions committee is basically looking for is strong evidence of research potential. If you have good publications out there, if you worked with a bunch of professors who can write, great letters of recommendation for you, that's very good, if you want to get a good PhD admit. The other thing which I did was that I was driven by this very strong instinct of following my interests. Whatever I found was interesting, I just followed that blindly. And that fortunately led me to Stanford. There's like a number of ways it could have led me astray, I feel, in some ways, or maybe to not be at Stanford and maybe somewhere else. But I think it was a good heuristic for me because I was interested in AI, and by following my interests, I was able to, gain useful skills, do cool research, which played a very important role in me being admitted here despite my crappy GPA. So what advice would I give to young folks such as yourselves who are maybe just getting started with AI or maybe a little bit further along as well, is basically that you should not depend on your university coursework to teach you anything. If I depend on my university coursework to teach me everything I know, I would not know a lot. This would be mostly empty because whatever I learned by myself. And the good thing is that AI has become so democratized that there are 101 resources out there for interested folks to, learn on their own time. So don't be passive and wait for someone to teach you something. You have to go out there and teach yourself. And it's not hard. It's definitely doable. The educational resources are there. The computational resources are there. The data is there. You've got everything. Second thing is that if you really want to be noticed, then you should aim for mastery over your domain. Now, maybe I kind of exaggerated saying that, I had all these opportunities fall into my lap thanks to Ashwin and Ravi. The truth is that they would not have sent these opportunities my way if they didn't feel I was qualified enough to deal with it. So they felt that, I at least had some skills. So the more skills you have, the more you focus on self-improvement and becoming a master of whatever field, and this generic advice doesn't apply only to AI, then there will be folks who will approach you rather than the other way around. So you won't be the one applying to 100 different companies saying, hey, please, can you give me a job? It'll be the other way around. When people see that you have done cool stuff, they will reach out to you and contact you and, try and get you on board to work with them. So that's what I would say. Focus for mastery, whatever the domain, not necessarily AI. And if you're looking into AI specifically, there's two things which you need to look at. One is you need to have really good software development skills if you want to build applied AI or ML systems, because it's not just enough to understand theoretically how to build a model. It's also important to understand how to deploy a performant model which meets time, computational, and latency constraints. And that only happens when you have solid software dev skills, ideally with some experience of actually working at the hardware level, or at least having an appreciation of how things work at a hardware level. I think the most impactful class which I ever took as an undergrad was a computer architecture class, even though I don't do anything related to computer architecture nowadays, simply because it helped me gain an appreciation of how things work under the hood. The other thing that you should master is the math, the theoretical underpinnings of everything that you're learning in AI and ML about different models, different types of classifiers, regressors, all that good stuff. The reason for that is that you don't want to be another person who is just doing import scikit-learn or import TensorFlow or whatever. You want to actually be able to have the background to design novel methods to tailor them for specific tasks rather than just using something directly out of the box. That's good. That's better than nothing, but you could be better. And like I said previously, once you aim for mastery, then you need to master everything, right from the high level theoretical underpinnings of ML and AI to the low level things of how these things work, and how you can make them faster. And yeah, don't be like me and don't be so sensitive to rejection. Take risks and ruthlessly pursue opportunities, even though a lot of those pursuits will end in failure. Like that's just part of life, rejection, failure, that's part of life. You need to get over it, get used to it. And yeah, don't be afraid, because at most, what do you have to lose? If someone says, let's say you apply for a thesis and someone says, yeah, no, we're not taking new students at this time, or they don't reply. Like, how does it affect you? It's not going to ruin your life. You have nothing to lose, you have everything to gain. Maybe they'll say yes. And so from a purely rational and logical standpoint, you should take risks and you should pursue these opportunities, whatever it is, whether it's thesis, research interns, some interns, jobs, whatever. And so I'll just end quickly with, this quote from Alice in Wonderland. So Alice is at this crossroads, she's kind of lost, and then she asks the Cheshire Cat which way she should go. And the cat says, it depends which way you want to go. And then Alice is like, doesn't care, I don't much care. And then the cat says, if you don't care where you're going, then, doesn't matter which way you go. And a lot of people misinterpret this because they miss out on the last part, which is not mentioned in the slides, in the next slide. So they make it sound like it's very important that, you should know exactly where your destination is, that you should always head only in that direction, be fully optimal. I disagree. I think you should explore more. So if you look at the full conversation, Alice says that she wants to get somewhere. Doesn't matter where exactly, but she wants to go somewhere. And then the cat says that, okay, if you want to go somewhere, you just need to walk long enough, And so I think the real mistake here is not that, I think the real mistake here is that people are stagnant. They don't go anywhere. They just stick at that crossroads. They're so paralyzed by the fact that I don't know where to go, so I'm not going to go anywhere. I'm just going to let life take me where it wants to take me. Don't do that. Do something. Explore, move in some direction, and then we'll see where life takes you. So if you're interested in AI, broadly move in that direction. Broadly move in whichever direction you find interesting. Use your instincts to guide you. Use your interests to guide you. But keep moving forward. Don't be static. That's the only advice that I can give you there. And yeah, that concludes my presentation. And yeah, if anyone has any questions, I'll be happy to answer them.
Yeah, I think, yeah, we have some questions. So how do you start off writing or contributing to research papers as early as you had? So I think you started from around your 2.1 or 2.2. So how could one go about, grabbing the opportunity?
Yeah, that's a good question. So typically the best types of research that you do would be under the supervision of an experienced researcher. That would either be a professor at your college or a senior scientist at a research lab. So if you have the privilege of being in a good university, like let's say a BITS or IIT or something, I'm sure there'll be people on your campus who are doing cool research. So get in touch with professors as early as possible. One good heuristic for this is attend their classes even if you're not registered. Be an active participant there. Ask intelligent questions. Professors noticed when someone is paying attention. Talk to them after class. Go to their office hours. Build up a connection with them, and then say, "Hey, I'm interested in this. Exploring this further. Can we work on a project together?" The other alternative: apply for research internships. Go to a research lab. If you're not in BITS or IIT or a good research university, you can always write to professors at these places. And the way we write for thesis or something, just write to them and say, "Hey, I'm interested in working with you." Like I said, you have nothing to lose just by writing.
Right. Another question is, how did you balance internships, extracurriculars, exploration, networking whilst maintaining a good CGPA?
Are Baba, what good CGPA? I don't have a good CGPA.
Yeah.
I did not maintain any balance. And I did not do any internships. During college, I interned with TCS after I graduated. I was afraid, the whole point of my presentation, that I was afraid to apply for internships, so I didn't do it. So I took the safe option, which was to just sit on campus and continue my thing. Extracurriculars, nil, absolutely nothing. Exploration, sure, I had plenty of time. The advantage of not going to class, that you have plenty of time to explore. Networking, again, very limited because I'm fundamentally not a very social person. And so, yeah.
Right. Okay, I think you already covered this, but just to spell it out, any reason why you didn't do an off-campus thesis by the time you had, by that time you had an amazing profile and there were profs or universities that had DL labs and working on many different fields?
Sure. I'll just go it again. It's because I had extreme rejection sensitivity, and I was afraid that if I write to a professor saying, "Hey, can I do a thesis with you?" they'll say no, and then I'll feel bad. I know that sounds, when I say it, that sounds silly, but that would really have made me feel very bad. So yeah, extreme sensitivity to rejection, as I mentioned, is one of my fundamental flaws, which I am working on. Yes.
Right. Okay. Okay, so this is not a question, but so Harshal said, "Hi Sanket, thanks a lot for giving this talk. But if you're interested in the self-driving space in the US, then definitely check out comma.ai. They're approaching the problem in a very different manner." So
Sounds
Harshal is
fun. I will
actually,
check them out. Yeah.
yeah, Harshal is actually one of my seniors who graduated last year and is working at this cool robotics startup in India.
Oh, pretty nice. Pretty nice.
Okay. Yeah. Okay. I don't see any other questions. If someone has any questions, just put
I
them
see
in the
someone is
chat.
asking, why is there Windows icon on your taskbar? That's because I put it there just for fun. I'm actually running Ubuntu, so you can do whatever you like with it. So I put this. Yeah.
Yeah. So there's one question: how to approach teachers and faculty in an online semester since we haven't been able to interact with them properly?
Honestly, that's not something I have a lot of experience with, because back in my day, everything was offline. But one thing I will say is that if the faculty members have online classes, online office hours, then it would be definitely worth attending online office hours. I don't know what BITS does, how they're handling the whole online situation. I believe they have handled it suboptimally based on reports which I hear, but I'm a little out of touch. But if a professor has online office hours, that's a great way of interacting with them. And then speaking up during class is again good, because as someone who has like been a TA in an online class, it's very demoralizing for the instructor. When you're giving a lecture or something, you're trying to teach something, and then you ask, does anybody have any questions? And there's pin drop silence, and everybody has their cameras turned off, and you don't know if anyone's paying attention or not. So it takes a lot of courage to stand up, whether it's online or in person in a classroom, to stand up and ask a question, because we are always afraid of being judged. Like, what are our classmates going to, think of us for asking this question? Maybe we are appearing like idiots because, we don't understand and everyone else is understanding. I want to reassure everyone that if you haven't understood something, it's very likely that most of them haven't understood it. And so there's absolutely no shame or anything in standing up and asking a question. So be bold enough, take the initiative to stand up, to ask questions, to interact with the professor as much as possible. Remember, if you don't do it, they are not going to interact with you if you don't initiate. So if you want to approach them, then you have to be proactive in classes. Yeah.
Okay. So I think another question was, what factors do you think were the key factors or the main factors that helped you get into Stanford? So I think this is more from the point of view of your profile. Which points on your profile contributed more to this?
Yeah, so that's easy to answer. I think that the biggest contributing factor was the fact that I had done research, like a lot. And, research which resulted in things like publications and good letters of recommendation. So it's not just enough to do cool research. that research has to be sort of, structured, directed, and have a good conclusion. Otherwise, it's hard to, you can say that I worked for 2 years on XYZ problem, but if you don't have tangible results to show for it, that just has like less of an impact. So I think the advantage of taking those gap years was all that unfinished work got published. So that was like a nice, good termination point. Yeah.
Right. Okay, so we have a few more questions. Did you do
Yeah,
any
sure. I have plenty of time, by the way. So I am more than happy to sit here and answer everybody's questions. So yeah.
Did you do any bioinformatics course during your BTech, or how did you
No,
become interested in bioML?
I did not do any bioinformatics course. On paper, on my transcript, you will see that I've done a reading course on biomolecules. So a reading course in bits is something like, it's just set up between you and your faculty member, and they tell you to do something like read some papers or textbook. And so I did this reading course with Ravi himself again. And he was like, yeah, for this course, go to this useful structural biology textbook, which was, molecular modeling and simulation by Tamar Schlick, which was pretty good read. But no formal coursework, because in addition to my many flaws, I do not like exams. So I do not like taking a course for the sake of, I'll take a course, I'll audit it to learn things, but I hate giving exams. So I will not voluntarily take a course which has exams.
Right. So I had done some projects on CV by just by following OpenCV documentation, but still I have confidence issue how to overcome this experience.
It's a very good question. And, I still have the same confidence issues myself. So like, there's always a thing, like you always question yourself, like, am I really good enough for XYZ? And the answer is that, you shouldn't be trying to evaluate yourself. Let others do that for you. So if you feel like, you have at least some understanding of OpenCV, and for example, you're applying for a computer vision internship, there are always these nagging doubts, which are like, will I get selected for the internship? Do I have enough computer vision skills? I think that, there's no limit to what you can learn. So at some point, you just have to say, hey, I'm just going to go for it. I'm going to give it a shot. If I get selected, great. If I don't get selected, I have nothing to lose. I will try again after increasing my knowledge.
Right. Okay. And so there's this another question, but it's pretty long, but I'll just sum it up. So one issue in online format is that you can't talk to professors so much. And in that scenarios, you don't have many project opportunities. So what are some of the other ways in which you can gain experience or add something to your profile?
Good question. So I would say that there's a lot of scope for doing independent projects which look good on your profile. And so the first thing you want to do is to make sure that you have the requisite background. And a lot of online courses will have, like if you look at Coursera, many of them will have some sort of project component at the end, like a capstone project. That is a good starting point. That's a good thing which you can put on your CV. You can also do a little bit of independent exploration with, websites like Kaggle, which run all these machine learning challenges. Again, the goal here is not to win the challenge. The goal here is to build up a portfolio and to actually learn new skills by taking part in those challenges, so that, you collaborate with other participants, you learn from them, you put forth your best effort, and basically that's there for people to see that, hey, this person tried this interesting technique for this challenge. Doesn't matter if it worked or not, that's a different story, but it's a good starting point. And then when you want to talk to a professor, you can go and say, hey, I've done all these cool things independently on my in the past, and therefore I feel that I would be a good candidate to help you out with your project. So, yeah.
Okay, so another question is, when you're working on a research, if it results in a failure, how do you overcome the negative feeling? And should we try again in another way to move on to another project?
Now this is an excellent question. And I would say that it depends on what stage of your research career you're at. I'm guessing that most of you, including the person asking the question, is an early stage researcher, maybe an undergraduate student. And so when you're doing research, like I said earlier, you should try and do structured research, which is done with a professor or a research lab. And so you should typically let your advisor, your research advisor, decide whether it's worth pursuing the same problem but from a different direction, trying again, or maybe if you know it's not worth trying at all. You should probably defer to their expertise in these matters because they would typically have a good idea of what works and what doesn't work. I think we were talking about this in the morning as well, Vedant, which was like, a lot of research is incremental. Like there is some existing research out there. You go through that, you go through all the literature, you read papers, and then you feel that, hey, I have this idea that if we change this one thing, we can actually improve on this method. So you're building off of existing methods which have been shown to work. So it's quite likely that you won't fail if you do that. If you try something like completely wacky and new, then you're in uncharted territory. But it's rarely the case that you're in fully uncharted territory. And when you are in that kind of territory, you should depend and trust your research advisor to guide you through those those unknown regions, basically.
Right, right. Oh, yeah, that makes a lot of sense. So, many research projects that we do at an undergrad level don't amount to solid research. What are some things to focus on when doing research to make it impactful, significant?
Again, another excellent question. And I would say, again, like I said, try and do structured research, which is under the supervision of a professor or research scientist at a lab. And when you're doing structured research, like let's say you're doing a project in bits, okay, with a professor, don't just run after any project under any professor. Try and look at the track record and see how much is this person invested in this project. If it's a large scale project which has multiple stakeholders, if there are multiple people on working on it, then kind of is a good indicator that people are serious about this and they will want to take it through to completion. And when it's taken through to completion and results in a paper publication, then that's automatically a good thing, as opposed to something which isn't, which does not materialize. The second thing I would say is that you maybe want to talk carefully with other students who are already in the lab or who have worked with that particular professor and see what their experience has been like. And they are pretty good indicators of whether this person is interested in taking something through to completion. And a professor's publication record is often a good indicator of that. Like if you look at Ashwin's publication record, he's like very prolific. He collaborates with so many people. He does a lot of cool research and he publishes a lot. So if you are in BITS Goa and you work with AppCare or specifically with Ashwin, then you're more likely to have something which ends up as a tangible product. Of course, you have to put in the effort as well. But under his guidance, I'm sure that if you are persistent enough, it will end up as something productive. But if you work with, I don't know, maybe some professor who's not really been publishing much, you'll get a project, you'll get that A grade, sure, but that won't amount to anything more than that grade on your transcript, which in the long term is not very significant. So yeah.
Okay, so any specific red flags that one should look out for to avoid hostile work environment?
Oh boy.
Yeah.
That is another amazing question. I would say to avoid a hostile work environment, the best thing that you can do is talk to existing students in a lab, because I've seen that personally. A lot of my fellow PhD students are like constantly bitching about the advisor, saying, "Oh, my advisor doesn't have meetings with me. Oh, my advisor doesn't listen to me. Oh, my advisor just asked me to write this paper and did not even bother to review it before we submitted it." Um, I would say that, this behavior does not materialize out of thin air. It's likely been going on for a while. So a lot of people are like, whatever, the research is interesting, we'll just forge our own way forward and ignore whatever the advisor is doing or not doing, which I don't think is the right approach to take to a PhD. But anyway, they do that. But the point is that this sort of behavior is not going to be like a surprise to you if you do your research, if you talk to enough people and figure things out. So yeah, to avoid a hostile work environment in a research lab, always talk to the students or members of the lab who are working there first. Yeah.
Okay. Yeah, I think that's all the relevant questions that we had. Unless anyone has any more questions, I think. Great. So thanks for joining, Sanket. Thanks for staying up late at night.
And no, this is normal for me. This is the life of a PhD student, right? Like we're often up pretty late. So
Right.
yeah.
Right. Okay. So thank you everyone for joining. We'll have the last session at 5 p.m. IST today, where we have 3 more speakers. Right. See you then. Okay. I think there's something. Okay. No. Yeah. I think we're done.
Okay, sounds good. Yeah. And if anyone has any questions, like feel free to reach out on LinkedIn or something. Just put in my name. I think you should find my profile. And yeah, I'll be happy to connect with you. Yeah.
All right. See ya.
Cool. Bye bye, everyone.